Hello, this is Lesson 4 of Precalculus, Combinations of Functions, corresponding to Section 1.4 from the College Algebra textbook. And this is Ruth Trigstead, your instructor. Let's get started with functions involving arithmetic expressions. To begin with, we have f of x equals 3x squared minus 4, and we want to find f of 2x and 2 times f of x. F of 2x is equal to, instead of 3x squared minus 4, it's equal to 3 times 2x squared minus 4. 2x squared is 2 squared times x squared, or 4x squared. So we have 3 times 4x squared minus 4, which simplifies to 12x squared minus 4. Then if we find 2 times f of x, this is 2 times f of x, which is 3x squared minus 4. We distribute the 2 through to give us 6x squared minus 8 for a final answer here. And the reason that we're looking at these two functions is to note that f of 2x is not the same as 2 times f of x. So it's important to note the differences and pay close attention to what you're doing with these functions. Then we have f of x equals 3x squared minus 4, from which we will find f of x plus 2, f of x plus 2, and f of x plus f of 2, starting here with f of x plus 2. So instead of f of x, we have f of x plus 2. Wherever we have an x, we'll replace that x with x plus 2 in parentheses. So we have 3 times x plus 2 squared minus 4. X plus 2 squared is the same as x plus 2 times x plus 2, which we would think of, if you remember foiling from intermediate algebra, x squared plus 2x plus 2x plus 4 gives us x squared plus 4x plus 4. Now distributing our 3 through x squared plus 4x plus 4, we have 3x squared plus 12x plus 12 minus 4. And it looks like we can simplify one step further to give us 12 minus 4. We can write that as 8. We end up with 3x squared plus 12x plus 8 here. Then to find f of x plus 2, this is just the function f of x, which is 3x squared minus 4, with a 2 added to that function. So 3x squared minus 4 plus 2 simplifies to 3x squared minus 2 when we take negative 4 plus 2. Now we're finding f of x plus f of 2, which is f of x, 3x squared minus 4, plus, instead of f of x now, we're looking at f of 2. So wherever we have an x here, we're going to replace that x with 2. We have 3 times 2 squared minus 4. And let's simplify a bit. So 3x squared minus 4 plus 3 times 2 squared is 4 minus 4. Then 3x squared minus 4 plus 12 minus 4. Negative 4 plus 12 minus 4 would give us 4. We end up with 3x squared plus 4 here. Looking at all three of these functions together, f of x plus 2, which is equal to 3x squared plus 12x plus 8, f of x plus 2, which is 3x squared minus 2, and f of x plus f of 2, which is 3x squared plus 4. We can see that these are all different. And so again, like with a multiplication of functions or numbers times functions, we want to be really careful of what we're doing here when we're conducting arithmetic operations on functions. So let's go on to arithmetic operations, function arithmetic. And in this case, we're going to start with the sum of functions. So if you look in your book, there's a chart that gives you all of the rules here for adding functions, for differences of functions, quotients, products of functions. You can look at that, or I've tried to kind of combine that into these examples here, where our first example is for f of x equals 2x minus 1, and g of x equals 2x squared plus 1. Find f plus g of x. So what we do here is f plus g of x, the rule for this is that it is equal to f of x plus g of x, and then I replace f of x with 2x minus 1. I replace g of x with 2x squared plus 1. Combine like terms to give us 2x squared plus 2x. You can see that minus 1 plus 1, we have 0 there. So our final answer here would be 2x squared plus 2x. We're also going to look for the domain of f plus g of x before we go on. To find the domain of f plus g of x, we look for the domain of f of x. Well, 2x minus 1, I can put in any number for x that I want to here. So the domain of f of x is all real numbers. The domain of g of x, which is equal to 2x squared plus 1, again, I could put in any value that I wanted to for x, and that would be legitimate. So the domain is all real numbers. The domain of f plus g of x would only exclude values that were excluded from the domain of f of x or from the domain of g of x, and since there are none, there are also no exclusions from the domain of f plus g of x, so our domain here is all real numbers. Then we're going to look at the difference of functions. We have f of x equals 2 over x minus 1, and g of x equals 3 over x minus 2. We want to find f minus g of 2. Well, f minus g of x is equal to f of x minus g of x. Replacing that x with 2, we have f minus g of 2 is equal to f of 2 minus g of 2. So starting with f of 2, f of 2 is equal, f of x is equal to 2 over x minus 1. If I replace that x with 2, I have f of 2 is equal to 2 over 2 minus 1. G of x is equal to 3 over x minus 2. If I replace that x with 2, I have 3 over 2 minus 2, which looks like a problem, doesn't it? For 3 over 2 minus 2, we would get 3 over 0. That is not defined, right? We cannot have 0 in the denominator there. So because of that, there's actually no solution here. That the solution does not exist, or the combination of functions we can't do. But let's look at the domain of f minus g of x here. We know that we're probably going to have to exclude that value of 2 because we can see it didn't work when we tried to use it in our computation. But to find the domain of f minus g of x, we go and we look at the domain of f. The domain of f is going to exclude 1 because if putting a 1 into this function f of x would give us a denominator of 0. So we know that x cannot be equal to 1. Looking at g of x, we can see that x cannot be equal to 2. We kind of already knew that, right? Well, the domain of f minus g of x excludes any values that are excluded from the domain of f or the domain of g, so it's going to exclude both 1 and 2, resulting in a domain of negative infinity to 1, union 1 to 2, union 2 to infinity. Okay, let's look next at the product of functions. For f of x equals the square root of 7 minus x and g of x equals x plus 2, we want to find f times g of 3 here. So rather than f times g of x, which would be f of x times g of x, we're finding f times g of 3, and that would be f of 3 times g of 3. Okay, so f of 3, to determine what f of 3 is, we look at f of x, and wherever I have an x, I'm going to replace that with 3. So we have square root of 7 minus 3. For g of 3, we look at g of x. Wherever there is an x, I replace that with 3. So instead of x plus 2, we would have 3 plus 2. Then simplifying, the square root of 7 minus 3 is the square root of 4, or 2. 3 plus 2 is 5. And then finally, 2 times 5 gives us 10 for an answer here. If we want to find the domain of f times g of x, we look for the domain of f of x, and we can see here f of x is equal to the square root of 7 minus x. So for the domain here, whatever is under a square root sign, in this case 7 minus x, has to be greater than or equal to 0, telling us that negative x has to be greater than or equal to negative 7, or that x, remember, if we multiply through an inequality through by a negative number, we need to flip that inequality sign. So x is going to be less than or equal to 7 here. For g of x, which is equal to x plus 2, there are no restrictions on the domain. The domain is all real numbers. The only restriction on the domain of f times g of x comes from f of x, which tells us that x has to be less than or equal to 7. So our final answer here for the domain would be negative infinity to 7, including 7. Let's look next at the quotient of functions. For f of x equals 2x minus 1 and g of x equals 2x squared plus 1, we want to find g over f of x. And it's important to pay attention here. G is on top and f is on the bottom. So for g over f of x, we're going to have g of x over f of x. If it was f over g of x, we'd have f of x over g of x. And you'll see both of those quite often. So we're going to then replace g of x with 2x squared plus 1. We're going to replace f of x with 2x minus 1. And we have our final, this can't be simplified any further if you play with it for just a minute. So g over f of x is equal to 2x squared plus 1 over 2x minus 1. And now to find the domain of g over f of x, we look at the domain of f. And let me change colors here. So the domain of f, which is 2x minus 1, all real numbers, no restrictions. The domain of g, all real numbers again, no restrictions on the domain of g. But we do have some issue going on here, because if we're throwing f of x into the denominator, we need to make sure that f of x is not equal to 0. And that tells me that we don't want 2x minus 1 to be equal to 0, right? What value would do that? Well, we have to make sure that x is not equal to 1/2. So 2 times 1/2 would give us 1 minus 1 or 0. So our only restriction on the domain of g over f of x here comes from the denominator we get when we put g of x over f of x. And so our domain tells us that x cannot be equal. Our domain is, excludes the value of x equals 1/2. So our domain is negative infinity to 1/2 union 1/2 to infinity. And that is our domain. Okay, let's go on and look at the difference quotient. We have a lot of things going on today. The difference quotient is f of x plus h minus f of x over h. Okay, usually this will be given to you on an exam. It doesn't hurt to memorize it, but I don't think you probably will have to know it from memory. For f of x equals x squared minus 2x plus 1, let's find and simplify the difference quotient. Okay, so I'm going to start with the difference quotient here, which would be f of x plus h minus f of x over h. I'm going to replace f of x plus h with, so right here, this is going to be our f of x plus h. And what I'm doing here is I'm looking at f of x, and wherever I have an x, I'm going to replace that x with x plus h in parentheses. Okay, so for f of x plus h, we have x plus h squared minus 2 times x plus h plus 1. And then the other thing I'm careful of doing when I'm writing down the initial first step of a difference quotient problem is we have minus f of x. So this is f of x right here. You can see it's the same thing as that we have for f of x up here. I make sure to put brackets around f of x, because otherwise I've seen a lot of students forget to carry this negative through. Okay, so the other important thing is to make sure that in each step of this problem you show h in the denominator. Let's go on then to simplifying. So next we have, well, x plus h squared is the same as x plus h times x plus h. Might help to write it off to the side. So we have x squared plus xh, which gives us a plus 2xh, and then plus h squared. And then we distribute the negative 2 through to the x and the h here. So we have minus 2x minus 2h. We bring the plus 1 down. And then next we distribute a negative 1 through to x squared minus 2x plus 1 to give us minus x squared plus 2x minus 1. all over h. We can simplify here a bit. If you notice, x squared minus x squared adds to 0. What else have we got? Negative 2x plus 2x adds to 0. 1 minus 1 adds to 0. So I can just skip writing those terms anymore. In our next step, we have 2xh plus h squared minus 2h all over h. And I'll go on to a new slide here to simplify. It helps to factor the h out of the numerator, in which step we would get 2x plus h minus 2 times h over h. Then we can easily see that we have 2x, if I can write, let's see, let me erase that. We have 2x plus h minus 2 times h over h, or times 1. My final answer then is going to just be 2x plus h minus 2, and this is our simplified difference quotient. Next, we have g of x equals 3 over 2x plus 1, and again we're going to find and simplify the difference quotient. So I start by writing the difference quotient, which is g of x plus h minus g of x over h here. I replace g of x plus h, looking at g of x. Wherever I have an x, I'll replace that x with x plus h in parentheses. So we have 3 over 2 times x plus h plus 1 minus g of x, which is 3 over 2x plus 1, all over h. In the next step, and this is a little bit different here, but what I'm looking for is the common denominator. I'm looking for the least common denominator between all of the, or amongst all of the fractions within my fraction here. There are only two denominators showing, 2x plus 2h plus 1, 2x plus 1. So I'm going to take the least common denominator here would be 2x plus 2h plus 1 times 2x plus 1, and I'm going to put that least common denominator all over itself. So what I'm essentially doing here is I'm multiplying by 1, which is okay to do, right? We can always multiply by 1 without changing anything. And in the next step then, I will, and let me erase, I'm going to kind of erase and redo things here so you can follow along with what I'm doing. Okay, so the next step here, I'm taking, I have 3 over 2x plus 2h plus 1 times 2x plus 2h plus 1 times 2x plus 1. So if we multiply this fraction times these two factors, notice 2x plus 2h plus 1 would cancel out. We'd be left with 3 times 2x plus 1, which goes right here. And then we have minus, and now I'm going to erase again. Okay, now we're taking, oh, I don't want green. Let's see, let's try blue. Now we're taking 3 over 2x plus 1 times 2x plus 2h plus 1 times 2x plus 1. Notice here the 2x plus 1 over 2x plus 1 we can pull out. We're left with 3 times 2x plus 2h plus 1. The denominator, well, it looks messy here, it's fairly easy. We just take h times 2x plus 2h plus 1 times 2x plus 1. And so spend some time looking at those steps if you need to, but let's go on then to simplifying a little bit further. We're going to distribute the 3 through to give us 6x plus 3. We'll distribute the second negative 3 through to give us minus 6x minus 6h minus 3. And the denominator we haven't changed here. Then we see we can cross out a few things again. So 6x minus 6x adds to 0. 3 minus 3 adds to 0. We're left with negative 6xh over h times 2x plus 2h plus 1 times 2x plus 1. We can pull out h over h, and we're left with a final answer of negative 6 over 2x plus 2h plus 1 times 2x plus 1. Okay, moving on to the first try on your own for today. This is try on your own number 1. Compute the difference quotient, f of x plus h minus f of x all over h for the function f of x equals 3 minus x squared. And after you finish writing that down, we'll go on to the next slide. Function composition. And function composition looks like this. The way that we say this is g composed with f of x. So when we see an open circle here, that means composition, not multiplication. Multiplication would just be a dot. Open circle composition, and we would say g composed with f of x equals g of f of x. So let's work through some examples. For f of x equals x squared minus 2x plus 5, and g of x equals 2x minus 3, find f composed with g of x. So note this is different than g composed with f of x. And it helps to, in the first step, write out f composed with g of x equals, we start with f here, equals f of g of x. I always put this first step in because it just sometimes helps me to write things down along the way to keep from making mistakes. So I write f of g of x, and then I always do the next step where I write f of, and I put in parentheses what g of x is here, which is 2x minus 3. I can see that instead of f of g of x, I'm actually finding f of 2x minus 3. Now if we go back to that function f of x up here, wherever I have an x here, I'm going to replace that x with 2x minus 3 in parentheses. So I'll have 2x minus 3 squared minus 2 times 2x minus 3 plus 5. 2x minus 3 squared is the same as 2x minus 3 times 2x minus 3. We can go ahead and distribute negative 2 through to 2x minus 3, and we will end up with minus 4x plus 6, and then we have plus 5. 2x minus 3 times 2x minus 3, 2x times 2x is 4x squared. We have minus 6x plus minus 6x, giving us minus 12x, and then plus 9. Then minus 4x plus 6 plus 5 is 11. It looks like we can simplify a bit more. Negative 12x minus 4x gives us minus 16x, plus 9 plus 11 gives us plus 20. And we have our simplified difference quotient here. Okay, now for f of x, oh, I said that wrong. We don't have a difference quotient. We have our simplified composition right here. F composed with g of x. Okay. Now, for f of x equals 3 over x and g of x equals 1 over x plus 1, we want to find g composed with f of x. Again, start by writing out what g composed with f of x is. It's g of f of x, or in this case, g of 3 over x. Now, g of x is 1 over x plus 1. If we replace this 1 with 3 over x, we have g of 3 over x is 1 over 3 over x plus 1. To simplify, I want to get rid of that fraction within a fraction, and so I'm going to multiply by the least common denominator. So the only fraction we have within our fraction here is 3 over x. Its denominator is x. So the least common denominator of our fractions within our fraction here is x. So we multiply by x over x. So what does this do? That gives us 1 times x here, 3 over x plus 1 times x here. 1 times x is x. Distributing x through to 3 over x gives me 3. Distributing x through to 1 gives me x. So my final answer here would be x over 3 plus x. Now, for f of x equals x squared minus 2, and g of x equals the cube root of x plus 6, we want to find f composed with f of 1. We're putting a number here in place of the x. So f composed with f of 1, let's start by writing out what that means. It means f of 1. Okay, and now I'm going to be finding f of 1 is, look what f of x is. It's x squared minus 2. That means f of 1 would be 1 squared minus 2. That simplifies to 1 minus 2, or negative 1. So now we're finding f of negative 1. Well, you see that we have g of x given to us here. We really don't need it if we're only doing composition with the function f. So f of negative 1. Now we go back again to f of x, and here we're replacing x with negative 1. So we're going to have negative 1 squared minus 2. Negative 1 squared is 1. 1 minus 2 is negative 1. That's our final answer. All right, so f composed with f of 1 is negative 1. Try on your own number 2. The volume of a sphere of radius r is v of r equals 4/3 pi r cubed, where r is in feet. Suppose that the radius is increasing over time according to r of t equals 3t plus 2, where t is in minutes. Find the volume as a function of time. Hint, you are looking for v of t, the composition of v of r and r of t. It is not necessary to simplify your answer. This is actually a pretty simple problem if you just think about it a minute. So go ahead and write this down, and once you do, we'll go on to the next slide here, which is find the domain of g composed with f of x, where f of x equals x plus 1 and g of x equals square root x. So I like to find the domain of composed functions by looking, first of all, by writing out what the composition is telling us. Here, g composed with f of x is the same as g of f of x. And now that I've written it this way, I can look at f of x as being an inside function. I look for the domain of that inside function, f of x. The domain of f of x, which is equal to x plus 1, is all real numbers. And then I look at my outside function. G here is my outside function. The domain of the outside function, g of f of x, is, well, what am I doing with g of x? I'm taking the square root of x. So g of x is equal to the square root of x. If I'm looking at g of f of x, I'm taking the square root of f of x. So if I'm taking the square root of f of x for the outside function, I'm interested in what has to be true of f of x so that g is defined. So if g of f of x is equal to the square root of f of x, then f of x, whatever is underneath that square root sign, has to be greater than or equal to 0. So if f of x has to be greater than or equal to 0, that tells me that x plus 1 has to be greater than or equal to 0. Then x has to be greater than or equal to negative 1. So our restrictions on the domain of g composed with f of x come from the restrictions on the domain of the inside function and the restrictions imposed by the domain of the outside function. Here our only restriction is that x be greater than or equal to negative 1, so our domain of g composed with f is going to be 1 to infinity, or it's going to be negative 1 to infinity, including negative 1. Okay, then we have the domain of f composed with g of x, where f of x equals 2x plus 5, and g of x equals 2 over x plus 3. Again, I'm going to start by writing what f composed with g of x means. It means f of g of x. So my inside function is g of x, which is 2 over x plus 3. The domain here of g of x, I know that x cannot be equal to negative 3, so I'm just going to write what's excluded here. The domain of the inside function would actually be all values of x except negative 3. The outside function then, if we're looking at f of g of x, then the outside function is going to be f, and we're going to be taking f of g of x, or we're going to be taking 2 times g of x plus 5. So what values of g of x can I throw in here? I can put anything in for g of x, right? Doesn't really matter what it is as long as it's a real number, I guess. So we have 2 times any real number plus 5. There are no restrictions on what we can put in for g of x. Our only restrictions for the domain of f composed with g are that x cannot be equal to negative 3. And so our domain of f composed with g is negative infinity to negative 3, union negative 3 to infinity. So finally, we reach our last try on your own for today, number 3. Find the domain of f composed with g of x for f of x equals x minus 3 and g of x equals the square root of x plus 1. As always, let me know if you have problems with any of these, if you have problem solving any of these problems, and I'll be happy to help you out.